Good evening, everyone. I'm Hasini, a student coordinator of KIYE Foundation and host for the day. A very warm welcome to all the respected guests, mentors, coordinators, students, innovators, and future scientists are joining us live today. On behalf of ISRO Space Tutor, Kalam Institute of Youth Excellence, I proudly welcome you all to another inspiring session, Lecture 8 of S-Talks. This is not just another lecture series, this is a platform where dreams meet innovation and where curiosity meets innovation and where young minds begin the journey towards building the future of India. To everyone joining us live on YouTube from different corners of the country, welcome abroad. Drop a quick hello in the live chat and let us know your name and college name. Let us see the energy today. Wherever you are from today, we are all connected by one mission to learn, to innovate, to dream beyond the limits. And this is the true spirit of S-Talks. Before we move ahead, let us quickly understand what S-Talks makes so special. The S in S-Talk stands for Space, Aerospace, and Futuristic Technologies. This initiative was created with one powerful vision to inspire students towards science, research, innovation, entrepreneurship, and next generations on technology. S-Talks is a year-long mission featuring 52 lectures, 52 speakers, 52 topics, 52 hours of knowledge, and 52 weeks of inspiration. And every single Saturday, we come together to learn from experts, scientists, innovators, researchers, and industry leaders who are shaping the future for our nation. Because the future belongs to those who continuously work, adapt, and innovate. And our theme always reminds space is the next destination. Let's explore it together. Before we move to this exciting session, let us make this live session more interactive. Everyone in the chat, if you believe India is going to become a global leader in space and innovation type quickly India to stars. And wonderful. That energy is exactly what drives in innovation. Every great scientist, entrepreneur, and innovator once started as a curious student. And today's my live session might be turning point for young minds, for many young minds watching this live. And now, before introducing our guest speaker, let us take a quick look at a short audio visual presentation that showcases the vision, achievements, and impact of KIYE Foundation. Now, I would like to call one of our coordinator to play the AV, please. inspiring. KIYE is not just an organization, it's a movement empowering students with knowledge, leadership, innovation, and opportunities. Now, to share the impact of KIYE from a student's perspective, I would like to invite one of our dedicated student coordinator, Ms. Srileka, to share a few words about her journey and experience in KIYE. Ms. Srileka, it's over to you.
Thank you, Hasini. Good evening, respected dignitaries, mentors, and young leaders. I am Srileka, student coordinator of KY. Thank you for giving this wonderful opportunity to share my experience. My journey with Kalam's Institute of Youth Excellence started in 2023 as a volunteer at Inspire Hyderabad. It was the beginning of an inspiring and memorable experience that helped me grow personally and professionally. As a volunteer, I learned the importance of teamwork, communication, discipline, and responsibility while interacting with students, coordinators, and mentors. Being a part of KY gave me opportunities to attend several valuable programs such as National Science Day, Vigyan Vaibhav, and Kalam Space Convention. These programs enhanced my knowledge in science, innovation, technology, and leadership, while motivating me to explore new ideas and improve my skills. One of the proudest moments in my journey was serving as an attending coordinator for Kalam Space Convention. This role helped me develop leadership qualities, even management skills, and confidence in handling responsibilities, coordinating with participants, and managing event activities gave me valuable practical experience and taught me how to work effectively as a team. And today, being here at STUCKS, I feel like I am continuing the journey step by step. I would like to sincerely thank Dr. G. Satish Reddy sir for his guidance and inspiration. One thing I truly feel is behind every step we take here, there is always a voice that says, "You can do it." That voice is nourishing answer. Thank you, sir. My experience at KYE has been truly meaningful and inspiring. It has shaped my personality, improved my confidence, and motivated me to continue learning and achieving greater goals in the future. Thank you, everyone. Jai Hind.
Thank you, Ms. Srileka, for those warm and wonderful words. Your journey truly reflects the spirit of learning, growth, and leadership. How many of you are really interested in traveling to space? Drop your comment below. And now, the moment we all have been eagerly waiting for. It's my immense honor and privilege to introduce today's distinguished speaker, visionary entrepreneur, and inspiring innovator, Pawan Kumar Chandana Garu, a name that has become synonymous with innovation, determination, and India's growing private space revolution. Our esteemed speaker, Pawan Kumar Sir, is a co-founder and CEO of Skyroot Aerospace, India's first private rocket startup. Under his leadership, Skyroot created a history by launching of Vikram Suborbital, India's first privately built rocket, making a major milestone in India's private revolution. Sir completed his dual degree in mechanical engineering from the Indian Institute of Technology, Kharagpur, and later worked as a rocket engineer at the Indian Space Research Organization, contributing to major launch vehicles like PSLV and GSLV missions. His passion for innovation and technology inspired him to build Skyroot Aerospace with a vision of making more space, more accessible and affordable. Sir is widely recognized as one of the youngest and most dynamic leader in the Indian aerospace ecosystem. With a strong passion for technology and nation building, he has been inspiring thousands of young entrepreneurs and innovators across the country. His journey truly reflects the vision and the mindset to challenge the limitations. Through his work in aerospace innovation and futuristic technologies, he continued to motivate young minds to dream fearlessly and build solutions that can transform the future. What makes his journey truly inspiring is not just professional success, but the ability to turn ideas into impact. In an era where India is rapidly emerging as a global technology powerhouse, leaders like Pawan Kumar Sir are proving that Indian youth can create world-class innovations and contribute the future of global space exploration. Dear participants, if you are really excited to hear from him, flood the chat box with welcome, sir. Come on, everyone, let us give him a grand virtual welcome. And now, without any further delay, sir, the virtual stage is all yours.
Hello, hi, everybody. Good evening. Can you hear me?
Good evening, sir.
You can hear me. Just put up. Yeah, good. So great. So very good. Excited to see all of you, and also I must appreciate all of you because now is a Saturday evening, and all of you are coming and wanting to listen about space, about the future of the industry, and you want to hear that. That itself shows your passion and your commitment towards your future. And you are nothing but the country's future and the world's future as well. So it's very, very interesting, exciting to talk to all of you. And also I should especially appreciate Naresh for starting this initiative. In fact, overall, Kalamji is like an inspiration for almost every technocrat in the country, and he has with his relation and his inspiration from him, now he has taken on a mission to educate, inspire, involve the entire student community. And the way he's doing, the scale at which he's operating and engaging with all of you is really, really really fascinating, really, really exciting. And really good job, Naresh. Keep going, and thanks also for inviting me today. So I'll just start off with a quick story about me. Just to set the context. So I was born in a very small town, in Andhra Pradesh, in a place called Machilipatnam. And after that, I studied a few years there, and then my dad got a government job in Vizag. So at that time, the government job is something very important. So he took that. He moved from the town to Vizag, and then I did all my schooling there. And during my school also, I was I was a very bad student, extremely bad student. I have not never understood a lot of complex things. I used to be very average student, sometimes even really below average as well. And in fact, I remember the time where I got some around 50 marks or so in maths. That's how my journey started. And after, then after until my eighth standard, I was extremely poor student. And people were thinking, I was not even doing well. I was very, like, probably in the among the last in the school. uh, and then my parents thought, this is not working out for him. And probably maybe I'll put in a state. I used to study in ICSC syllabus. Then my parents thought that maybe that is too difficult for him. So my parents transferred me to state syllabus school. And then this school is very famous for like making people study very hard, and then get marks in get marks. So that's where I shifted to the school. But I think to a good surprise and to a good this thing, my teachers thought I was really good. So they thought that this guy, maybe because of the spectacles. I had spectacles from class three, so they thought that I'm very intelligent or I know a lot. But if you see, look at my report cards, is always like I was very bad. I was getting very bad marks. So people thought some my teachers, especially my maths teacher and science teacher, they thought I was good, and and then they encouraged me. And then somehow I never got that attention from teachers. All teachers thought I'm not a very poor student. And suddenly, when teachers started giving good attention, I to keep that attention, I used to study a lot. I started studying, and then while studying, I realized I really like maths. I really like physics. I really like sciences. And then that passion ignited me. And then my dad always wanted me to go to an IIT because I think most of you might be thinking, like, the IIT is like, going to IIT is like the dream of every middle class family. If they have a son, they want to go to IIT. If they have a daughter, they want to become a doctor, something like that. This is, we all face. So that way, even my dad had a very big ambition that we have to. My son has to go to IIT, but my marks, if you see, is very, very bad, very, very poor. So then when I changed the school, my teachers encouraged, and then I started studying. And from like the bottom of the school, I went to the top of the school in just a matter of 1 year. And then I was really got good at maths, physics. And was from almost a very bad student, became a good student. Then my passion for sciences and maths has started. And I thought maybe really I really have a chance to get into IIT. Then I studied very hard. And then I used to study, I think, one point of time 14, 15 hours a day. And then got into with a lot of effort. In 2 years I got into IIT. Then I joined IIT Kharagpur. I did mechanical engineering. And after doing mechanical engineering, there also I was not a great student. But I really liked the towards the end of my my studies, I really liked. I got passion in the engineering. I really used to enjoy studying, understanding, go a few layers deeper. I used to really go deep, whatever I used to do. And then but after spending like few, spending few years in IIT, then I thought like as a mechanical engineer, the most fascinating thing a human built is a rocket. So I need to work on rocket. I used to get inspired by these rocket launches being done by ISRO. So I thought, and I'll join ISRO. So so typically like doing a starting from IIT, people want to go abroad, leave the country, go abroad, and then probably you'll have a lot of prospects there, outside, and you can grow faster. And IITians are very well known across. So, but then I decided that I want to stay in India. I want to stick with my passions, and then like ISRO came to campus that year, and then I joined ISRO as a scientist. And then after joining ISRO as a scientist, I was lucky to be part of India's largest rocket program called LVM-3. That is a rocket. It's called the Bahubali rocket of India. So this is the same rocket which launched the spacecraft Chandrayaan 3, which landed on the south pole of the moon, near the south pole of the moon, first time in the world. So I had the opportunity to work on that rocket. I spent 6 years at ISRO as a scientist. I got the real feel of really I became an engineer only after joining ISRO. Because I got a feel of how things are done, how rockets are made, how difficult technology is built. So I could see I could take the front row seat of the industry, and I could see how it is done. And also as that time I was watching the global industry. At that time. Uh, and at that time, like, SpaceX is doing really well. Some private companies like Rocket Lab, based out of New Zealand, is doing very well, and they just started launching. And there's so many other private companies, wanting to start. Right, and there is Amazon founder Jeff Bezos started his space company at that time. So all this things started happening, and a constellation of satellites started building. Instead of like previously, satellites used to be very big and bulky, and the big rocket used to launch these satellites. And then now it has transformed to small satellites. Most of the satellites are small satellites, less than 500 kilograms, and then create the network around the Earth. Because finally satellites are all about coverage. You get communications, you get Earth observation, so many applications. So whatever, today we cannot live without space. We have GPS, we have, for example, many of our homes may have dish, which gives TV to our homes. And then, like, in fact, in India, even fishermen use space images, space data which ISRO gives, and find the right shoals of fish, so that, and they save billions of dollars worth of fuel by, because the satellite guides them where to go. So like, and agriculture farmers use it. It's used for urban planning, defense uses it. So without space there is no life today. And we use and then the transformation which is happening is that satellites are becoming smaller, and then, like, and then you launch a large amount of satellites around the earth, and then you do business around that, and it's a $500 billion business globally. So that, and then it's growing, and access to space was very difficult even at that time when we started. At that time, when I was at ISRO, there were not many launches happening, and then, but the demand was very high for rocket launching. So that's when I thought, like, it's a great opportunity, and India needs more and more private sector. Not only government, ISRO has been doing very well, very successfully, but still as a country we are only 2% of the global market as the space. So I thought, like, private investment should come in, private entrepreneurship should come in, people should push the boundaries, and then more companies, more investment should go, and then India should become like second to none, in space. So we're already like among the five nations globally, so even in commercial space, our share should be high. So with that mission and with that like ambition, and also, like, I was very passionate that the future in our lifetime, space will be open to everybody. So that means, like, now if you see, how many of us have gone to space? None of us has gone to space, but everybody want to go to space at one point of time. So space is right now still not accessible to everybody, but yeah, but space is something fascinating. You can do a lot of things with space. You can, if you can access space easier, you can actually make communications, create communications for billions of people. You can get high speed internet to every rural area. You can get like, you can get billions of people will get connected. You can create Earth observation. You can create navigation, even better navigation. So like that, even there's endless applications for space. And now there is thought process of putting data centers in space. Now we all use chat gpt, we all use AI. Tomorrow, like, the AI is going to get stronger. It needs more energy, it needs more data centers. And in future, I think all the data centers, the lowest cost of compute, even for AI, also will be in space, because you have almost 10 times more energy than on earth in space. So the energy also from space, it will come and will be used for AI. So that is the future. Very very interesting. We are in the transition phase in the global space sector right now, and there is more and more need. So in 2018, I started after working 6 years in ISRO. At the age of 27, I took that leap to leave my very comfortable job, which I really loved. I really loved working at ISRO, and I thought it was very very important to start. It was a very great opportunity, and also very important for the country to have a large private company. So I quit my job, started Skyroot Aerospace in 2018 along with my colleague at ISRO, my very good friend Bharat. We both, in fact, were flatmates in at ISRO. We were, very close with each other. And he's electronics engineer, I'm a mechanical engineer, and yeah, we thought like, we can partner together in building this company. And we started the company in 2018. And at that time, there's not even policy in private space sector. You can't even build and launch a rocket to space because there was no policy. There was no funding environment to build rockets and launch. You have to have hundreds and hundreds of crores, even so maybe even thousands of crores. So there was no funding environment. No fund knew what is space sector. Most of the investments are was going in e-commerce, in fintech, in other fields. But space is completely unknown. And even without policy, no investors were even ready to take the risk to put it. So in that environment, we started the company because we were all prepared. I was very prepared for the even waiting for 10 years, and give it all in. And because I really knew that this is a great opportunity and we should make this happen. And thanks to the government, within 2 years of starting Skyroot, they have announced the space reforms where private sector became accessible to private people. And then we signed the first ever MOU with ISRO. Now we get access to ISRO facilities. Even 1,000 crore facility which ISRO has built, now we get access to them. So that way, like Skyroot built our rockets faster and better. And in November 18, 2022, Skyroot has launched India's first private rocket to space. It's Vikram S. We named it Vikram after Dr. Vikram Sarabhai, who's my big personal inspiration. He's the founder of the space program. In fact, because he started the space program in 1960, and then built an ecosystem, and ISRO has built an ecosystem for 60 years, in India. That's the reason why we are able to do what we are doing. So that way, we wanted to give a tribute to him, and we named our rockets as Vikram. And in fact, the rocket motors, the engine which will drive the rocket, we named as Kalam. So in fact, because of in honor of Dr. APJ Abdul Kalam ji, who has contributed to the country like no other, contributed to rocket technology like no other. And so as a tribute, our rocket motors are called Kalam, and the rocket is called Vikram as a tribute to our great scientists of India. And with that, we have launched a historic launch, India's first. And Modi ji, after the launch, in fact, he gave, one of his Man Ki Baat episodes was only about Skyroot. And he said that this rocket and this launch proved that sky is no limit for youth in the country. And that was a great, it's a great message from him, which inspired all of us. And so after that, then that was Vikram S was a small rocket. It is two-storied building tall, and it just touched space. Space. NASA defines space as anything above 80 kilometers. So the rocket has just crossed 80 kilometers, did some experiments, and then fell in the sea. So with that, that is so it was more like a test launch. We proved structures, we proved materials, we proved propulsion, we proved electronics, we proved the trajectory simulation, all the simulation software. We proved launch operations, assembly operations, all that. So it gave us a great learning, and we became one of the very few companies in the world who's able to even launch a rocket to space. And after that, that is a great foundation. Now the next big leap is launching a orbital rocket. That means launching a big rocket which can put real satellites into orbit, which is a commercial capability, because the market is almost, it is set to become, just launching satellites to orbit is going to be a $50 billion market globally, with only like less than, only around five players doing it, from the private companies. Only two of them are doing regular launches. So the world needs more launch. And because of that, we started building Vikram 1 aggressively. And now, as we speak, happy to share that the Vikram 1 has been fully developed, and then it has moved to Sri Harikota. That is where the launch happens. It's a spaceport where the rocket launch takes place. We moved the rocket to the spaceport, and then we started assembly there. In next few weeks, we're attempting to launch India's first private orbital rocket. It will be a first test flight for that, and soon we are going to launch regularly to orbit, putting satellites into space. First time in the country for the private sector, and will be one of the very few companies in the world doing it. And being an Indian company, 100% designed in India, 100% manufactured in India, it's a really proud moment that what we are doing at Skyroot. We are able to do all these things with fantastic team. We have now almost close to 1,000 people team, and then the average, the median age of the team is around 27, 28 years old. So all youngsters are building, the rockets, cutting edge rockets from India for the world. So that is what is happening. And then as we grow further, as we get more and more bigger and more successful, we're going to maybe hire even several thousands of other people, and then we are going to have, like, we need some really best of the best talent, from the country, coming together, working for us, working for the entire ecosystem, maybe many of them working for ISRO, right? And all that building together and create the future of the space industry. So this is orbital rocket which is going to launch, and then we're going to launch more. And then in future we're going to build bigger rockets, reusable rockets, and maybe at one point of time, maybe we will send astronauts to space, and maybe, like, we can send some of you on a holiday to space as a space tourist. And then, like, we offer from there, even we can do even bigger exploratory missions from there. So it's a the world is an opportunity, and then space industry is moving. So there is opportunity in the rocket launching side, like what we are doing. There are so many companies building satellites, special type of satellites which can watch even in the night time. Satellites can give high bandwidth internet directly to your mobiles. And then high and broadband connectivity to your homes with a very high speed where you don't have access to internet. So that is going to get transformed in the next 10 years. Satellites, rockets, all going to become regular. Just like we're in the time of Wright brothers in 1903, they just started launching the few flights, and now we have millions of flights, flying every day. So the similar way, the rocket industry is also, or the space industry also, it only started in 1950s. And then now, we are only doing one launch every day on average in the entire world. Across the world altogether, if you put together on average, one launch every day is happening. But still, it's still the very beginning phase. There will be a future where thousands of launches take place every day. So that is the future which want to create, which will be created, and that requires, like, so many people, working, putting their minds and giving their life and giving their entire passion, energies towards doing this. And also now in the future, even data centers which will do compute for AI also will be in space. In the future, and a lot of materials will be manufactured in space, because space has no gravity and it has pure vacuum, and it creates environment to create special materials which are far better than what you can produce on the earth. So space will be, there will be factories in space. And also, in earth, as we know, earth, in the last 200 years, the earth population has become 8 times. So from 1 billion people, now we are 8 billion people. And there is no enough resources. As we expand as a species, as a humans, we expand more over the coming hundreds of years. Earth may not be fully sufficient to grow a very large population. We are an intelligent species. We want to spread across the world, and across the universe. And then, space is the only way to expand. So humans will be beyond Earth. Humans will be living across the solar system, and that is the future. So I always say, if steel has built modern civilization, space will build future civilization. And so space is a very, very important sector which will define the future of humanity, with a lot of applications which can transform the lives of everybody on their daily lives. And with that, that's the reason why our mission statement at Skyroot is always been, to open space for all. We want to create a future where space is open to everybody. Everybody can access space data at very, very nominal cost. A farmer can check the health of their farm on their smartphone. Everybody will get access to high speed internet. You have compute from space. You have manufacturing. You use items from space. You can go to space as space tourist. You can go and work in space, in a factory in space. You can live probably, in other planets, etc. So there's a very Space is the future. It's called the next frontier, and we're making baby steps now. Step by step. First steps. Slowly, step by step, we will. First we launched a suborbital rocket. Now we are launching an orbital rocket. And now we'll start commercial launching satellites, and then start even go bigger, bigger, bigger. So that's the journey. And so that's the reason why I think India needs several lakhs of people working in the space sector, which will power the future of the space sector. And today, maybe there are only 20,000 people who are working in the space sector, including ISRO. And in future there will be several lakhs of people working just in the private sector. Now there are almost 4,000, 5,000 employees. All have been in the last, most of them, employment has been generated in the last 3 4 years, thanks to the privatization by the government. This has started. So in future, this is just the beginning, and most of the companies are in the very initial phase. Now, as they go to commercial phase, revenue phase, profit phase, more and more talent will be needed, and then that will be a great opportunity for all of you. And some of you should start companies like me. The reason for telling my story is like, coming with almost nothing. Not even a good student. There is not privileged. And coming with, if I can build and recently, in fact, last week we announced that Skyroot has become India's first space tech unicorn. So just in 8 years, less than 8 years of the company, we became a unicorn 10,000 crore company. That is because of the potential. That shows that India's space potential is higher. And if nobody like me can build a company, a unicorn company, matter of 8 years, with no background, no great school background, I think everything is possible, anything is possible. So many of you should start companies, many of you should work for the space sector, many of you can work on your other passions also, which can create impact in the world. So I think it's very, very important for you to think. In fact, a few very clear principles which helped me, which could help you, is that one thing is that always think big. So for example, when we wanted to start a company, I didn't want to start a small company. I wanted to start something very big. What is the biggest problem in the world right now? For example, I'm in the space industry. I wanted to solve the biggest problem in the space industry, which is rocket launching. Very few people are able to launch a rocket to space, and the access is not there. So even though it looks very, very daunting, very, very a very, very big risk. Starting a rocket company needs thousands of crores of capital. How will you do it? So that way, many people who are feared by that, they don't even attempt. But I thought, like, that's the best way is to target something very, very big. And then people generally think that the probability of success will be low, because the moment risk is high, your chances of failures is more. But actually, in my experience, is actually reverse. So when you try ambitiously something very big, governments want to support you, people would want to work with you, you'll get investors would want to invest with you. So it is actually becomes opposite. So it becomes, the whole world will help you achieve things, because it's a highly impactful and highly something big. So always think big. Whatever you do, if you want to become best in a career, how you think about, how can I become the best space engineer, how can I become the best rocket scientist, how can I become the best entrepreneur in this field. So it's very important to think, that way. And second thing is that be very sound in the fundamentals. Always one thing which helped me is that from the school time, from the college time, I always never took anything from the subject. I used to think, I used to reflect on, why is this, why not this, what is the fundamental, why is this the theory required, who invented the theory. I used to go 2 3 levels down. I used to spend my go very deep, understand the sound fundamentals of things, and that really helped me. Engineering is all about understanding very good fundamentals. You need not be from a great institute, you need not be anything, you may not, marks also may not be very high, that if you're very sound in the way of thinking, fundamental thinking or first principle thinking, that will really take you to the next level. And you can solve any problem, whether it is, you can solve any problem. Like, it can be in technology, it can be in business, it can be anything, whatever you want to do. I think first principle thinking is, it becomes extremely important. And also, like, as you target something big, always you have to aim for the sun. If you just target the biggest thing, when you aim for the sun, there are only two options: either you reach the sun, you know or worst case, even if you fail, you'll at least get to the moon, and you'll be better than most other people. So always it's important to think big, always shoot for the big things. So that is another message in our life, and also something very important for your generation or at your time, as you are many of you, some of you are in school or getting into colleges, and some of you are in college will be graduating soon. I think you should be like the masters of using artificial intelligence, because now is the decade of artificial intelligence. There'll be the future of artificial intelligence. So many, so the best people, so many people think that AI is going to take away the jobs. But more importantly, if you are the best user of AI, you will be the most sought after, people in the market. So you should know how to use AI to do better things, right? So AI is already very capable, and it's already like thinking, and it is already like solving problems. So now your strength lies in using AI to the best, and that way I think you see that you should not get outdated. You should become like the best users of AI. So people will find it tough jobs who can't use AI, so that is, but if you are able to use AI, you will be like very well soft, and in future even engineering problems will get solved by AI. Like for example, CAD, CAM, everything will be automated with AI. Even structural analysis or like simulations, AI will do better. So what you have to do as a person is like, probably you should be like a chief architect, how to use the tools and do even better and faster. That should be, so usage of AI should be good. That's for that, even sound fundamentals are very important. So the moment you have a better understanding of the whole concept, better understanding of the whole technology, you'll be able to even guide. You can use AI and do so because you're thinking at even higher level. So that is where it's very important. And always I've seen, whether it is in employees or whether it is in the all walks of life, I've always found that passion and spirit, somebody who says, who are like, whose spirit is that they never give up. They can find out anything and find solutions. And then people who are very good attitude, they always succeed. Even somebody who's like probably the topper of the car of the part, topper in the subject, or somebody who's like technically exceptional, but if they don't have that spirit and knowledge, and if the passion or drive, I've seen that they generally are not as successful as the people having the passion and spirit. So I think that is very important. So always do what you like, what you are passionate about, so that you give all the best. And then when you naturally are able to give your best, and you really do something which you love, you'll automatically get better than most other people, and you'll be very competitive, and you'll like that, and you'll become the best expert in that field, and you'll do really well in that field. So always passion has been better than knowledge, etc. You should have knowledge, but passion always is a step ahead of it. So yeah, so I, and also very important to take risks. Like for example, I have always taken very unconventional choices. Right. For example, I've studied in IIT, but I've not gone abroad or taken, I've gone to the either high-paying sectors like fintech or other sectors. I wanted to be a technocrat. I'm an engineer. I joined a government company. Typically nobody joins a government company from IIT, because you generally get very big packages out of that. And then I chose that I wanted to become a scientist at ISRO, and I joined ISRO. And then my salary was very very low at that time. So the government salaries, just imagine. So at that time I took that risk, while parents think that I'm sending my kid to an IIT so that they can earn in crores. But I never ran after money. So, and that never excited me. That has never uh, driven me for passion. I always thought that if you take up something, if you're working on something, you're almost, let's say you sleep up to 8 hours, the remaining 16 hours you're thinking about that. So when you're thinking about, say, up to 16 hours, either you're doing something or you're thinking about it. When you're about your work, about your career, etc., it has to be like something you're really passionate about. Engineering was my passion, space was my passion, rockets was my passion. So I took that, I took that unconventional choice of doing it. So never run after what everybody is running after. If everybody is running after something, that is maybe a wrong direction, because so you think you choose your own direction, you choose your own passion. With that, you will have like a really, really good chances of success. And India's future is the youth. Today, almost 50% of India's population is below 25 years old, and that is going to power the next 30 50 years of India. So you all are going to power the next generation of India, and India is going to be a great technologically advanced nation than what it is today. because we are the land of engineers, we are the land of exceptional people giving their heart. We are frugal. We have a great DNA. We have high precision engineering capability. We have a great manufacturing ecosystem. We have a very ambitious and forward thinking leaders who are also at the helm right now, who are pushing the country to the next level. So it's a best time to thrive in India. So it's very important to use the best of the technologies, put your passions all together, put your all your efforts, do the next big thing, and become one of the world's best in the field of your choice. So with that thought, I thank again the opportunity to speak with all of you. It's really really wonderful, to share my learnings and and then what the future of the industry looks like with all of you, and wish you all the very best and great success to all of you. Thank you.
Thank you so much, sir, for that incredible, inspiring session. Your words have not only educated us, but also motivated every young mind watching this session. And now we move into one of the most exciting part of today's event, the interactive question answer session. Participants, this is your opportunity to directly interact with our esteemed speaker, Pawan Kumar Chandana Garu. You may post your questions in the YouTube live chat. We can answer as many as possible. So, with your permission, shall we proceed?
Yes, please. Let's proceed.
Yes, sir. So we have a question from Vinay Bandala, sir. He's asking, so myself, Vinay Bandla, and aeronautical engineering, what is Skyroot's biggest technical challenge today in reaching reliable orbital launches? And how many young engineers like us contributing to solve it?
Yeah, so I think the biggest challenge is building a rocket in one full system. So that's the biggest challenge, because rocket has hundreds and hundreds of parts, various types of engineering streams coming together. You have electronics, you have materials, you have structures, you have propulsion, you have two three types of propulsion. So you have ignition systems, you have control systems, you have guidance, you have navigation, right? So it's a very very complex system. So I think the toughest challenge has always been, building a system all together which works in harmony. That's what a rocket is all about. And in fact, a rocket launch is only 10-15 minutes. It takes 10-15 minutes to go to orbit. So such a small flight, everything has to work, and everything has to work perfectly every time. And you can't add margins. You cannot have make it thicker. If you make the rocket thicker to reduce your failure the rate, the rocket will not reach orbit. So it's a very thin margin. So whatever your design margins are very thin. So very very tough challenge to design a rocket, bring all the systems together and make them work. So I think, yeah. So this is the biggest challenge. Now we have passed that challenge. It took us many years to get to this point, and then from here we'll go on to mass produce them, and then like we'll have more and more people across the fields, from designers to manufacturers to production to everything across streams. We will be needing more and more talent for our future.
Thank you, sir. Shall we proceed to next question, sir?
Please, yeah, go ahead.
Sir, a question from Siri. What are the major engineering difficulties in modern aerospace systems like reusable rockets, hypersonic vehicles, and advanced aircraft?
Yeah, I think one of the biggest toughest system is the materials. So today, the materials required for re-entry. So today re-entry is one of the toughest problems. So today we have only ablative materials. So ablative materials are like consumables. So you have to replace them for every flight. So and the future is all about reusable rockets. Reusable rockets, you cannot replace any materials. For that matter, they have to be used hundreds of times, sometimes thousands of times. And anything coming from space to ground is a very tough technology. For example, so right now as you speak, there's so many meteorites, small things falling on the earth. They all get burned up. They don't fall on the earth. So that much, atmosphere, Earth's thick atmosphere burns everything down. So with that, with that kind of a thick atmosphere and re-entry at that speeds, if you want to bring down something back to earth and launch again, it's I think one of the biggest challenges. Whether it is hypersonics or whether it is reusable launch vehicles, materials is one of the biggest toughest challenge to solve.
Thank you, sir. With your permission, I would like to invite our next speaker, invite one of our student coordinator to ask his question. Mr. Mahavir, please proceed.
Good evening, sir. What are the biggest challenges Skyroot Aerospace as a private organization faced while entering global markets, sir?
Yeah, so in fact, like globally, the good thing is that very few companies are there who are launching the rocket. So everybody is looking forward to a new rocket launcher. So we are also working with customers across the world, and the biggest challenge is that I think it is many people also have a challenge that how an Indian private company can build some cutting edge tech. So making them believe that we can do it. So Vikram S launch has proved it that we can do. Vikram 1 now the next launch is coming up, so that also proves that we have that capacity and capability to do that. So I think that our progress and our work has proven and gave them more confidence. And then now many we are looking at partnering with many of them to launch their satellites to orbit.
Thank you, sir. Sir, we have an interesting question from one of our audience, sir. Shall we proceed, sir?
Yeah, please proceed.
What kind of technological breakthrough do you believe could completely redefine the space industry in next 200 years?
Yeah, I think next 200 years is probably technologies like very high nuclear propulsion. Maybe if nuclear fusion is able to create the energy and that can power rockets. So it's a very clean, neat, radiation-free, high performance rockets will become very high performance. And so today we are all dependent on chemical propulsion. Chemical propulsion has a limit. So and now in the future, if something like nuclear propulsion, which is a clean nuclear propulsion, like using fusion reactors, etc., if that is there, that is also one thing which can actually propel the space industry forward, or like completely out of the box. Systems like warp drives, or issues where you can directly go to space in a different, like a magical sci-fi kind of a technology, right? So this could be some of the critical things which can transform in the next 200 years. Yeah.
Thank you, sir. With your permission, shall we move proceed?
Yes. Yeah.
Yes, sir. I would like to invite one of our student coordinator, Miss Neha, to ask her question. Miss Neha, please proceed.
Hi sir, I'm Sneha. So first of all, thank you for making time to inspire students despite your busy journey and responsibilities. Listening to your transition from ICICI to SSC and hearing about the dedication of studying 15 to 16 hours per day was truly inspiring, sir. Your words about choosing your own direction really stayed with me. I feel that behind such consistency during different difficult phases, there must be have some inner belief or mindset or thought that kept you moving forward even when things become challenging. I would love to know what that was, sir.
Yeah. So for example, during the IIT preparation, right? So I was really, I took it really as it went into my head that I need to get into an IIT. So that was like I was like rigorously. I had no choice. I mentally I cannot accept if I won't be able to get it. So I put my standards very high. I wanted to get into. I wanted to like work out, compete. With the best brains, and then like getting into the college. So that drive, because I knew that if you get into the best place, work with the I mean like study with the best people, you'll have a great future. So that drive has really made me get into study so hard and get into it. And even and after that I always worked hard, whether it is at ISRO also, I used to work very hard. I used to even study and do a lot of work on the weekends. On almost every weekend I used to work. And even today, now also I work almost 14 hours, 15 hours, 16 hours sometimes, even beyond sometimes, without holidays, every time. So because I love it, because it's again a passion, and I really enjoy what I'm doing. So now the mission is to open space for all, and that drives me. So that will in the next few years, next few decades will be like dedicated for that. And for that, building, I'm really inspired by doing such a global class company from India. So that makes me give push my best, give even give my give my all my passion and energy toward this, and that drives me. And then I don't feel that I'm working hard because it is 16 hours, 18 hours, because this is what the passion which drives me. Thank you.
So, with your permission, shall we move to an next question?
Yeah, please.
So, many students learn theory but struggle with research thinking. According to you, how can students develop a real research mindset from college itself?
Yeah, so I think again, I think you should get inspired by solving a problem. So, what is the biggest problem in your area of interest? You choose that, and then and solving a research problem, the approach is like pure scientific method. So you have to experiment with things. You have to go very deep. You have to understand the theory to a so much level that you have to get into the details. You get into so much attention to detail is what you have to give, right? So I think finally at the end of the day you can do anything if you really are passionate about the end goal. So for example, if you want to discover a new thing, you want to create a new process, you want to develop a new material, develop a new system, automatically if that drives you, you'll get into the research mode, you'll get to the details, you'll get to the best, you'll read all your papers, you'll connect with the best people. They will also want to encourage to talk to you because you're really passionate about this subject, so it automatically comes, right? So nothing nothing is all, everything is the motivation and the drive which makes things happen.
So, thank you, sir. One more question from our audience. While building rockets, what is the one technical challenge people outside the aerospace field usually underestimate?
I think it is system engineering, what I call it. At Skyroot, we say that every engineer is a system engineer because many people tend to, optimize one system. This is okay system. I'll only optimize this. But system engineering is that you understand the whole rocket as an architecture. It's like one whole thing. So you have, a little bit about every system, how things interact with each other. And then like, you design the rocket in a way that it works everything in a synchronized fashion together. So I think that is very, that mindset of system engineering, not only become very deep expert in one area, but also like, being able to think everything together, like, all the system working together in relation to everything together. This is called system engineering. I think that expertise is very underrated outside. People do not know. But I think that what makes, for example, I am a proud system engineer, so I think that what makes me different, even if it's engineering, because I can look at it as a big problem, as a full problem, a little bit of everything, and then create an architecture of a rocket or a architecture of a space system, right? So that is very, very important. So system engineering is, I think, one of the biggest superpower of the future engineers.
Thank you, sir. Shall we proceed with next question, sir?
Sure.
What is one mistake India should avoid while expanding its private space ecosystem?
Yeah, I think one mistake which India should avoid is that do not leave the private space ecosystem just to the just to the dependency of the global market. Because even the global market is the most driver for all the private companies, because it's a large market and we can build very competitive products and solutions from India. But it is also very important that we generate India also generates market internally, because India is a growing nation. India has a very ambitious future. So we need to be, second to none in, in creating our own space infrastructure. And then I think private sector can complement, even the current space program of built by ISRO. And so that the government should also utilize the services and capabilities and make a completely better space program as a nation. So that way, I think it's very, very important to not just have dependency on the foreign market. We should develop our own self-reliant internal market. For example, there's one very clear example is China. So China, because of like a lot of geopolitics, they do not have access to outside market, but companies inside China are thriving. And then they get full support from the government, and then they get a lot of internal market exists. So India, we have a advantage that the whole world is our market, but the domestic market is very limited. So the moment that is also sorted, will be even much more robust ecosystem, one of the best ecosystems in the world.
So, shall we proceed with next question, sir?
Sure.
Sir, space technology often inspires people through launches, but what silent research areas behind the scenes are really important?
Yeah, so I think one is the research on the hypersonic side of things. So like because the re-entry problem is also a hypersonic problem. And re-entry at very very high speeds, and it becomes plasma, gas becomes plasma, and so it's a different physics, it's a different level of problem solving. So that is one. And materials, like I mentioned, the current materials which we know of is not enough to build like future cutting edge reusable rockets which can work hundreds of times, thousands of times. So this is also another very very critical important thing to be solved. And yeah, so other than that, I think most of the, and also new types of propulsion systems, like I mentioned, beyond, can we go beyond chemical propulsion systems? Can we go to nuclear? Can we go to like any other type of new technologies, which can be like better, so that we are not we can go to space faster, cheaper, and also like even space exploration can be faster and cheaper. So that's the future.
Thank you, sir. One last question. Sir, as an aerospace engineering student undergraduate, what type of skill should we focus on work on during the course to the meet and the industrial standards in next 2 to 5 years and joining industry?
Yeah, I think propulsion is a very, very important field. So as you're an aerospace engineer, I am sure you'll have some courses on propulsion. So propulsion is something which is a very, very unique skill, and it requires more and more engineers. If you have that background, I think that will be really well sorted after skills, and you'll also create huge impact in the sector, because propulsion is like the heart of the whether it is a rocket or a spacecraft. So having that expertise and building that passion around that field is going to be a great benefit from you to the industry as well.
Okay, sir. Thank you, sir. Thank you so much for patiently answering all the questions and encouraging students with such positivity and clarity.
Thank you. Thanks everybody.
And once again, thank you to all the participants for being active and interactive throughout the session. Wishing you all, the entire team, grand success for the launch of Vikram Suborbital 1, sir. As we come to the end of this incredible session, now I invite Ms. Saharsha to deliver the vote of thanks. Ms. Saharsha, it's over to you.
Thank you, Hasini, for this wonderful opportunity to deliver the vote of thanks. Respected dignitaries, teachers, my dear friends and students, a very good evening to everyone present here. Myself, Saharsha, and I feel extremely honored to stand before you today to deliver the vote of thanks on behalf of KIYE Foundation, along with the entire organizing team of the Stock Lecture Series. First and foremost, I would like to express our heartfelt gratitude to Shri Pawan Kumar Sir for his valuable presence and inspiring words. Sir, your thoughts about space and science technologies have truly motivated all of us. Your journey and achievements are a great source of inspiration for students like us. Sir, your words have truly ignited scientific curiosity among our students and encouraged many to dream in the field of space technologies. We are deeply grateful for your time and effort in sharing your knowledge and experiences. Your journey and achievements have encouraged us to dream big. I extend my sincere thanks to our organizers for arranging this wonderful session. Special thanks to coordinators for their continuous support and guidance. I also thank all the participants for their active involvement and enthusiasm. Your presence made this even more meaningful and successful. We are thankful to everyone who worked behind the scenes to make this program a grand success. Before I conclude, I warmly invite everyone to stay connected with us for upcoming sessions. Join our WhatsApp channel, subscribe to our YouTube channel, follow us on Instagram. Thank you once again. Jai Hind.
Thank you, Ms. Saharsha, for those warm and heartful words. Today's session was not just about technology or innovation. It was about vision, it was about courage, it was about believing that young minds can create extraordinary impact. A heartfelt thank you to our respected speaker, Pawan Kumar Chandana Garu, for spending his valuable time with us and inspiring thousands of students today. And everyone, every participant watching this live, never stop learning, never stop questioning, and never stop dreaming, because the future belongs to innovators. And remember always, our theme, space is the next destination. Let's explore it together. Have a wonderful evening. Thank you, everyone. Jai Hind.
Okay, bye everybody. All the best. Thank you. Bye bye.
Thank you, sir. Thank you.